Hey guys, Jackson here. Today we're going to be working on 20 sample questions from a practice 2020 assessment for the TSI. So for our first question here, it says if there are 2.2 pounds in 1 kilogram, how many pounds are there in X kilograms? So this tutorial is going to take quite a bit of time on each question because I'm going to try and go very in-depth. Even though a lot of these are simple and you could probably do in your head, I think it's important to understand the process so when it gets more difficult, you're prepared and you have the tools to be successful. So let's reread the question. So there's 2.2 pounds in 1 kilogram, and it's asking how many pounds are there in X kilograms. So the way a concept I think that's important to understand to start this off is to understand that math is a language, just like English, Spanish. You communicate through numbers and symbols, just like you communicate through letters in Spanish and English. So when you write something in math, when you write an equation, it's always communicating something. And it's important to understand what it's communicating so you can connect it to the real world and say, does that make logical sense? Say like you have two balloons, and to write that as an equation, you would have like R, which is the number of red balloons, equals 2, because you have 2 red balloons. So if you put R equals 5, that wouldn't make sense, because in reality, you only have 2 balloons. So now get into the question. So if there's 2.2 pounds, get to the pin. Why is it doing that? Oh, I need to pick a color. I see. Okay. So there's 2.2. Hold up, let me. The ink flow 100. Okay, there we go. There's 2.2 pounds. So I'll write that as P per every 1 kilogram. Write that as K. So if we're trying to find how many pounds are in X kilograms, if there's 2.2 pounds for every kilogram, that means to write this as an equation. Actually, let's backtrack a little. So P, let's write that over here, equals 2.2 in this scenario, in this language that for this specific question. And K is just equal to 1. So 2.2 of these equals 1 of K. So how would we communicate this with our understanding of math? Well, if we have 2.2 K, it's equal to P. Because think about this. Every time you write a statement, you have to check if it's true. If we plug in our 1 into the K spot, these parentheses show that I'm multiplying 2.2 by 1. And we plug in 2.2 where the P is. Is this statement true? Does 2.2 times 1 equal 2.2? Yes, it does. Therefore, this equation right here is going to be our answer. And it asks specifically how many pounds are in X kilograms. So you would simply replace K with X for your final answer, which would be 2.2x. Okay, next question. So the bar graph above shows the number of customers who shopped at a store Monday through Thursday of 1 week. If the number of customers on Friday was a 1/5 increase from the number of customers on Thursday, how many customers shopped at the store on Friday? So let's define what we know here first. Just erase this. So we know the number of customers on Friday. I'll write that as an F here. Was a 1/5 increase compared to the customers on Thursday. So that means to go from Thursday to Friday, Thursday is increasing by 1/5. So how do we communicate this algebraically as math? Because remember, math's a language. Everything you do in math is just communicating something. Sometimes it can be a little confusing, but that's what learning the basics and the concepts fundamentally, that's going to get you very far. So if we look at our graph here, on Thursday it says the bar graph goes all the way to 4. So on the left, we can see that for each number increase, it says the number of customers are in hundreds. So there wasn't 4 customers on Thursday, there was 400. So now that we have Thursday, how do we find Friday? Well, we know Friday is increasing, so right off the bat, we know it's greater than 400. So we can write for Friday equals 400 plus something. To find this something, we simply multiply the customers on Thursday by 1/5. So we have 400 times, and I'm using this dot as the time symbol because if you use the x symbol, that can become confusing when x is a common variable. So every time you see this dot, that just means multiply. So 400 times 1/5. How can we write this in a way that makes sense? Well, let me rephrase that. When you multiply a whole number by a fraction, the easiest way to do it is to just convert the whole number to a fraction and then solve from there. So 400 as a fraction is very easy to do. It's just 400 over 1. Any number can be put over 1 and its value doesn't change. Times 1/5. And when you multiply 2 fractions together, you just multiply the top times the top and the bottom times the bottom. So this right here is the exact same thing as this. So let's multiply our top. 400 times 1 is 400. And 1 times 5 is 5. I believe you should have a calculator for this, but if you don't, we know 5 times 8 equals 40. So 5 times 80 would equal 400. So 400 divided by 5 equals 80. So that's our question mark here. And if we add 400 and 80 together, that tells us that the number of customers on Friday was 480. So that's our answer. Okay, number 3. Last year, a bakery sold W loaves of bread. This year, the bakery sold 3 more than twice the number of loaves of bread sold last year. If next year, the bakery plans on selling twice the number of loaves of bread sold this year, how many loaves of bread does the bakery expect to sell next year? So let me just re-say the first part because I misspoke. So the bakery this year sold 3 more than twice the number of loaves of bread sold last year. So let's just start off by finding what the bakery sold last year. Or let's start off by figuring out what the question's actually asking. So it's saying the bakery it plans on selling twice the number of loaves of bread this year. And it's asking how many loaves of bread does the bakery expect to sell next year. Hold up, it's worded in a weird way. Next year the bakery plans on selling twice the number of loaves of bread as a previous year, basically. So Let's see here. Okay, it took me a second to look over that because this is actually a 3-step problem. So to find the amount the bakery expects to sell next year, we have to go from one year to the next. So last year, the bakery sold simply W loaves of bread. This year, the bakery sold 3 more than twice the number of bread sold last year. So how do we write that in math terms? Well, we know it's twice as much as last year, so we can multiply W by 2 to get that part. But it also says it's 3 more than twice the number of bread sold last year. So we know we're adding 3. So this is equivalent to the bread sold this year. But the question actually asks how many bread does it plan to sell next year? And it specifically says it plans on selling twice the number of bread compared to this year, which is the 2W plus 3 we just found. So basically, to do this, all we need to do is multiply everything here by 2. So 2 times 2W equals 4W, and 2 times 3 equals 6. So this would be our final answer. All right, moving on. Number 4. If 7p minus 4 equals 8, what is the value of p? So always write down, if you're able to, your equations, preferably on another piece of paper, because they don't give you a whole lot of space usually, but just somewhere is good enough, wherever you can manage. So we need to find p. So first things first, before PIMDAs, always make sure that your variables are on one side of the equation and your non-variables are on the other side of the equation. So to do that, we can add 4 to both sides to get rid of this minus 4. So these cancel out. And then we're just adding 8 plus 4, which is 12. So now we need to get p by itself. So how do we do that? Well, if it's being multiplied by 7, if we divide by 7 on both sides, that isolates p for us, meaning p is equal to 12 over 7. Number 5. Running at an average rate of 6 miles per hour, how many minutes would it take Kyle to run 3 miles? Okay. So when you have a form of measurement and you're converting it to another form of measurement, there's something called the train track method that is very consistent. For this one, you probably don't need it, but I would recommend practicing it with the train track method, so when it gets really confusing and complex in the future, you have a consistent way to always get the right answer. So if we want to write he's running 6 miles per hour in math terms, we can do it like this. So for every 6 miles, it takes 1 hour. So this is essentially the math way of communicating 6 miles per hour. This is a 6, by the way, sorry. So yeah. So for the train track method, you basically make one very long fraction. It says for our final answer that we need to see how many minutes it would take him to run 3 miles. So how do we do that? Well, the miles, thankfully, we don't need to convert here, but the hours we need to convert to minutes. So the way to do that is to put hours on the top and the bottom so it cancels out. And the reason this cancels out is because, remember, if you have the exact same thing on the top, and the bottom of a fraction, it's equal to 1. So we're essentially not changing, well, if this was all we did, we would be changing the value of the equation. However, what if we put something on the bottom equivalent to 3? Let's say n is equal to 3 and we had n on the bottom. That would also equal 1. Furthermore, if we have 1 hour and we're trying to go from minutes, we can write 60 minutes on the bottom. I'll just write 60 mins without changing the value of anything, because 1 hour is equivalent to 60 minutes. So we're essentially just multiplying it by 1, and you can always multiply something by 1. So that leaves us with, this is actually all you need to do for this specific one. Sometimes you'll have to go pretty far to go from one form of measurement to another, but this one's simple. So once you get to your, when you're left with your two forms of measurement that it's asking for, you have miles and minutes. Then you multiply everything on the top. 6 times 1 is 6. And it's 6 miles times 1, because miles we left. We didn't cancel out miles. Let me just indicate that the hour is canceled out. And then we have 1 times 60 minutes. And anything times 1 doesn't change. So Kyle's speed is 6 miles every 60 minutes. And if we want to simplify this, we can divide the top 6 and the bottom 60 by 6 to simplify the fraction. So this basically simplifies, to 1 mile every 10 minutes. And if you put 6 over 60 into your calculator, it will either give you 0.1 or 1 over 10, depending on the settings or the input you put into the calculator. So if you ever want to, if you're not sure of how to simplify a fraction, there is a certain thing you can do with your calculator that would give you this, if you're, for whatever reason, don't want to do it manually. Or it's too, I guess, complex to do manually, given the time that you have. So now we have our ratio. For every 1 mile, it takes him 10 minutes. But we're trying to find how long it takes him to run 3 miles. So let's think about that. Remember, math is a language, and everything written in math communicates something. This communicates he's running 1 mile. I'll put 1 m per minute. So if he's running 3 miles, and it takes him 1 minute to run every mile, or 1 mile takes every 1 mile takes, hold up, I'm sorry. This was actually incorrect, what I just did here. So this communicates he runs 1 mile per 10 minutes, not just 1 mile every minute. So if he runs 1 mile every 10 minutes, to run 3 miles, the first one would take 10, the second one would take 10 again, and the third one would take 10. So if you add up all those together, you get 30. So our final answer would be 30 minutes. Okay. So for question 6, let me erase everything real quick. So question 6 says, the dot plot above identifies the number of pets living with each of 20 families in an apartment building. What fraction of the families have more than 2 pets? So what is this question asking for? So we're trying to find the fraction and when you're trying to, this is always a good way to start every problem, is identifying what the problem actually is. Because, like, remember that bakery problem that we did last time? Often there's a lot of fluff and unnecessary details in these kinds of problems that can distract you from what it's really asking. So you can either underline the part that's specifically what the question's asking, or you can write it out, which is what I'm doing, because I like to see everything visually. This also helps if you want to go back to check your work. You can kind of see your train of thought and how you got to each answer. So you can also identify your mistakes a lot easier. So you don't have to redo everything when you make a mistake on a problem. You can just redo everything from the point of the mistake. So it's asking for the fraction of families with more than 2 pets. Wow, that is just the worst. What? Than 2 pets. So this is our question. So given, hold up, let me make sure it's not being cut off. Okay, it's cut off a little bit, but I think you can see it enough. So to find this, we need to look at the dot plot. So the dot plot shows, for each number of pets, it shows how many families have that amount. So for 0, that represents 0 pets. And we can see there's 4 dots on the dot plot for 0, which means 4 families out of the 20 have 0 pets. But remember, all we're looking for is the families with more than 2 pets. That's what the question's specifically asking for. So all the families that have 0, 1, or 2 pets are not what we're looking for. For this dot plot, we're looking for the families that have 3 and 4 pets. So for the 3 column in the dot plot, there's 3 dots. So that's 3 families of 3 pets. And for the 4 column in the dot plot, there's only 1 dot. So 1 family has 4 pets, which means out of the 20, a total of 4 families have more than 2 pets. But remember, we have to find it as a fraction. So to do that, basically what we do is just write what the question's asking for on the top of the fraction, the families with more than 2 pets, just erase that, over the total sample size, which is the 20 families in this case, so over 4. And to simplify this, we can divide the top and the bottom by 4. 4 divided by 4 is 1. And 20 divided by 5 is 4. Or no, is 20 divided by 4. 20 divided by 4 is 5, sorry. So 1/5 would be our final answer.